Hello, my awesome chemists. I hope you're having a wonderful day. Today, we are going to calculate how much heat is transferred from one object to another. So, we know that heat is transferred from hot to cold. So if I hold my cold water bottle, I'm going to transfer heat from my hand to the water bottle because it's colder than me. But if I hold my coffee cup, then my coffee cup will transfer heat to me because it's warmer than me. So we know that heat is transferred from hot to cold. But how much heat is transferred? Well, it depends on several factors. So let's say I have 2 beakers of water, both at room temperature, 25 Celsius. What would happen if I take a hot copper penny, put it in one of them, and take a hot big block of copper and put it in the other one? Which one would receive more heat? Well, the one with the big block. So what factor is that? Well, that has to do with mass. The big block has more mass, so it can transfer more heat to my water. Okay, what if I had 2 beakers of water at room temperature again? In one of them, I heat a copper penny until it's 50 Celsius and I put it in the water. In the other, I heat a copper penny to 100 Celsius and put it in the water. Well, which one would transfer more heat? The one with the penny that was at 100 Celsius to start with. So what factor is that? Well, it's not exactly temperature, it is the difference in temperature. So if my water was at 25 Celsius, this penny would be 25 Celsius difference. This one would be 75 Celsius difference, right? And so the one that has a bigger difference in temperature is going to transfer more heat. Okay, finally I have my 2 beakers. Now I'm going to put a hot copper penny in one of them, and then in the other one I'm going to take a piece of wood about the size of a penny and put it in and both were starting up pretty hot. Which one would transfer more heat? Well, if you think about it, it's probably the copper penny. And that's because of something called specific heat capacity. And the symbol for that is C. So let's talk about what specific heat capacity is. Specific heat capacity is the amount of heat that is required to raise 1 gram of my substance by 1 degree Celsius or by 1 Kelvin. Remember, a difference in a Celsius is the same as a difference in a Kelvin. So this should sound very familiar. This is the same definition as a calorie, except a calorie is specific to water. So a calorie is basically the specific heat capacity of water. It's how much energy is needed to raise 1 gram of water by 1 degree Celsius. Specific heat capacity obviously is different for each substance. The units for it, since it's the amount of heat, so it's in joules per gram, for 1 gram per Celsius. So joules per gram Celsius or joules per gram Kelvin, either one. So in your packet, you have this table of specific heat capacities, and you see water, methyl alcohol, aluminum, gold, lead, all kinds of different things. Notice that the metals have lower specific heat capacities relatively. Why is that, or what does that mean? Well, if you have a low specific heat capacity, that means that you need very little energy to raise your temperature. So imagine it's a very hot summer day and you go outside, there's a metal bench and there's a wooden bench. Which one would you rather sit on? I would prefer to sit on the wooden bench because wood has a higher heat capacity than a metal, which means it takes a lot of energy for wood to change its temperature versus metal. It takes very little energy to change its temperature. So the metal bench is going to be at a higher temperature than the wooden bench because it's absorbed the same amount of heat, but yet it's changed its temperature to a much higher temperature. Same thing if it's really cold and snowy outside, I'd still rather sit on the wooden bench than on the metal bench because the metal bench will be very, very cold. It can release a little bit of energy in order to drop its temperature. So specific heat capacity, again, is how much energy I need to give it in order to raise its temperature by 1 degree Celsius. So the metals will have low specific heat capacities, meaning that they can get hot or cold very, very easily with very little change in energy, versus something like water, look at that number. It has a very high specific heat capacity. That means it takes a lot of energy to change the temperature of water. That's why water moderates our climate on Earth, because we have large bodies of water, and so those bodies of water can absorb a huge amount of energy before the temperature would change. So let's put all this together. The three factors that we have talked about so far are mass of the object, the difference in temperature, and the specific heat capacity. So if we multiply all three together, you're going to get the quantity of heat. And the equation is Q equals mc delta T. Q is the heat that is measured in joules. So this stands for quantity of heat. It's in joules. M is your mass, which is in grams. C is the specific heat capacity. And that's in joules per gram Celsius or joules per gram Kelvin. And then this is the difference in temperature between the two objects. And this is going to be in Celsius or in Kelvin. Okay, so let's use this equation to calculate the heat that is transferred from one object to another. So the first example says how much energy is required to heat an iron nail with a mass of 7 grams from 25 Celsius until it becomes red hot at 750 Celsius. So how much heat do I need to give it, or it needs to absorb, in order to go from 25 to 750 Celsius? So since I'm calculating the quantity of heat, I'm going to say Q is equal to mc delta T. And Q is what I'm solving for, because I'm solving for the energy, which is the amount of heat that's transferred. Mass of my iron nail is 7 grams. C for iron we can look up in our table right here. 0.449 joules per gram Celsius. And then delta T is final minus initial. Delta of anything is always final minus initial. So 750 Celsius minus 25 Celsius. And multiply it together. You get 73,000 joules, or you can say that that's equal to 73 kilojoules. Joules, remember, are a very, very small unit of energy, and so most of our answers that are in joules are going to be really, really big numbers. Okay, let's look at the second example. We want to calculate the quantity of heat in kilojoules needed to warm water from 25 Celsius to 95 Celsius to prepare a cup of coffee if the cup holds 250 milliliters of water. So we want to heat our water. So I'm going to write Q equals mc delta T. I highly recommend when you write Q equals mc delta T, always write what substance it's for. You'll see that that's helpful a little bit later on. So I'm looking for the quantity of heat, so I'm solving for Q again. Mass of the water, they don't give me the mass of the water, but they do give me the volume. And I know that water has a density of 1 gram per milliliter. And so this 250 milliliters are equivalent to 250 grams. So I can use that. C for water is 4.186 joules per gram Celsius. And then my difference in temperature, remember, is always final minus initial. So 95 Celsius minus 25 Celsius. And you get 2,300 joules, which is 2.3 kilojoules.